After the tone, state your name, followed by the pound or hash sign. Thank you. You will now be placed into conference. To mute your line, press *6. To unmute, press #6.
These are unlike any typical capital project. And similar to that, it's also a unique enough project that many plant engineers have never had to do major migrations. You know, it's a unique project for each facility, and so what we find out in industry is, you know, typically you don't have a nice library of lessons learned from previous projects or established processes for these particular type of projects. So that's part of what we'd like to discuss today as well. A couple of housekeeping items before we get started. As I mentioned, if you've joined a little bit later, we'd like everyone to mute the phones on their end. Because we have a multi-person panel today, we can't work it to selectively mute. So we'd like everyone to mute on their end if that's possible. We have over 300 attendees today, I believe, so we're going to be unable to open up the phones for open discussions. The format that we would like to have is using the chat facility on the WebEx. So if you have any questions throughout the presentation, feel free to put them in the chat box. You can send to everyone or send to everyone so that everyone can see the questions and we can select those at the end. As you put, you're welcome to add questions to the chat at any time, and we'll monitor those and collect those for the Q&A session at the end. There will be a follow-up email for everyone who registered that will have recordings and links. So if you miss something or there's some key piece of information, you don't have to scribble everything down and take notes. This will be available afterwards. I believe they said it might take several days to maybe 1 week to get that email out with all of the links and the recording to a spot that everybody can get to. Our social media group has also set up a Twitter site for this, hashtag migrate. So as people want to Twitter about the webinar, you can use that hashtag. It's migrate, and use Twitter as well throughout the presentation. And then because we can't have open phones and discussions at the end, unfortunately, we'll give you a link at the end to be able to share your stories and your feedback and things that you'd like to share. And what we'll do is we'll collect those into a blog entry that we put on the ISA and Maverick sites, and that'll be included in the email as well, so that we'll have a collective group of comments and experiences that you guys choose to share at the end of this. Our agenda today, if everybody can make sure and mute, please. Our agenda today will go through the introductions of the panel. Nick Sands will go over industry trends for migrations. Matt Sigmund will go through DCS migration planning. John Boyd will present a migration case study, and then we'll have a pretty significant Q&A session at the end. And I think most of the panel is open to sticking on as long as needed to answer as many questions as possible. Introductions. I'd like to introduce myself. I'm Chad Harper, currently our Director of Technology for Maverick Technologies. Have 15 years experience in the DCS space, at least 12 of those in heavy migration work, mainly in the refining and chemical industries. We have Nick Sands, who has 22 years experience in the industries. He's a manufacturing technology fellow with DuPont and is also an ISA fellow. We have Matt Sigmund, who has over 20 years of DCS experience in a variety of industries: chemical, pulp and paper, pharmaceuticals. He's currently the director of DCS Next at Maverick Technologies. And then we have John Boyd, who has over 30 years of automation experience, recently migrating to some plants to the PlantPAX platform, and he will have our case study for today. And he is our Rockwell technology leader for Maverick Technologies. Between these four, we have experience in almost all of the major DCS platforms out there. So even though we won't be talking specifics on technology, I think between this group, we've seen just about every migration path that's out there available. So it should be a good discussion. With that, I'd like to pass the baton over to Nick Sands, who is going to discuss some of the logistics and data on control system upgrades. So give me a second to pass it over. Nick, would you like to take over?
Yep. Thank you so much, Chad. Can you hear me okay?
Yes.
All right, great. So my name is Nick Sands, as Chad said, and I'll try to just talk a little bit about some experience in terms of the background for drivers for changing and upgrading your control systems, some of the experiences and the projects I've been with as a user and gathered from other folks around the issues, and also some of the benefits. So there's some studies done by the ARC advisory group that kind of give us a picture of what's coming at us in terms of obsolescence of the automation built. And just a reminder, if you can mute your phone, that's always helpful for everyone else on the line, as Chad pointed out today. 65 billion, that's, 65 billion years ago, the dinosaurs ruled the earth, and we have 65 billion in automation systems that starts to look more like the dinosaur side of the spectrum. Reaching the end of the useful life, it served its time well, but we're going to have to look at replacing some of that infrastructure. And that can be quite a challenge. Sometimes you can justify that just on obsolescence. It's getting old, end of useful life. And sometimes that justification, you have to wait for failures and increasing failure rates in terms of the equipment. There's a number that's been bandied about for a good while back from an ASM, an Abnormal Situation Management Consortium report. It talks about the $20 billion a year lost in U.S. industry from upsets like this, things that could be related to the failures of the control system. So the experience from the projects I've been working with in the past few years, there's a few things that have really been driving us towards upgrades. I think this is a strong industry trend as well, moving away from our proprietary-based DCS systems and control systems towards systems that can exchange information with our business systems, where we can turn that data that's in the process into business information that helps us compete better in the marketplace, know what inventory we have, better deliver on promise to customers, and those kinds of things. And that connectivity through OPC and other technologies, that's really important, like the S95 series of integration. That's a great guide to that. The security requirements have driven a lot of concerns I've seen around control system upgrades. If you're governed by NERC or the American Chemistry Council, and you're trying to meet some of the security requirements that have come up lately, and it gets down to the point where certain operating systems and certain applications have to be controlled or eliminated. And so we see ourselves facing control system infrastructure replacement just to meet those requirements. And I really think that the future holds just more requirements around security. One of the places that we typically isn't a big driver for us anymore, it used to be, was process control improvements itself, the ability for new algorithms and new functionalities to be able to improve how we control the process. So that's not as much a driver. It's rather low on the list, but sometimes we see if it's not obsolescence, we still see that some functionality improvements around the human-machine interface, the operator interface, giving more capability, more knowledge to the operator, and in some cases designing our operator interface to compensate for the turnover we're facing in operations personnel, where we have to retrain people, and we can make that control system provide some of that training information. It's really powerful for helping us operate our facilities. I think those are some of the big, trying to just keep it short and simple, some of the big pushes in terms of industry trends for upgrading. But I'd like to share with you some of the things I've learned and things that are common also from my experience talking with others around maybe things that we don't do correctly on some of the upgrades. And just a reminder again to mute your phones. Everyone has to mute individually since we're on a common line here with a panel of people. So the upgrade errors, I'll tell you, not understanding what we have in an existing control system tops my list of what we do wrong sometimes. There's a couple of ways that this plays out. One is we've got an existing system and someone says, we don't need to document what's in there, I just want whatever it does. And then we try to make an estimate around an upgrade project to move that functionality, a big question mark around what that functionality is, from one system to the other. And we'll see how that difficulty of estimating that question mark plays out. So another big one is to copy as is. Copy existing control functionality right on over to a new system. And, well, when we do that, a lot of times we don't take advantage of the functionalities of the new system. See that in particular around the HMI. And in HMI, we see oftentimes, well, we're going to replace an HMI, and folks want some kind of utility to convert their existing HMI to the new system. When they try to do that conversion of the existing HMI to the new system, we go through extreme lengths sometimes to propagate that older functionality, and we don't take advantage of the newer functionality. And I've seen this in cases where we have taken the symbology of a first-generation DCS, and 2 generations, 2 upgrade projects later, we're still building custom shapes and faceplates to replicate what our first DCS had, which replicated what our panel board controls had. Tremendous effort and investment and expense to propagate, that initial. No one around the plant ever can. Everyone that worked on that original system is retired. No one could tell you what it was, but we've still propagated that. Amazing. When we do that, when we replace the system, and even if you're doing a partial upgrade, like replacing the HMI, one of the common errors I've seen is to not provide sufficient resources for operator training. And when we do the operator training portion there, that's a lot of change. It's maybe not as challenging as years ago. We would put in a DCS, and it's the first computer the operator ever worked on, and the first mouse that they ever used, and those kind of things. Now everyone has a smartphone and an iPad and a computer, or many of those things. But that operator training is still really important. The process knowledge may be there, but you have to make sure people are really efficient in that, being able to operate the process safely. And it really can come down to safety that's impacted. I call it working on both sides of the glass, the design of the HMI on the one side and the operator training on the other. The last of the big errors that I've faced, and again, just trying to keep the list short for the limited time here because we've got a great case study that's coming up. Insufficient control engineer resources to put on the project because we don't understand completely what it is we had in the existing system. We don't understand what resources it will take to implement that functionality in the new system, and then we fall short. And that leads to the unexpected consequences from those errors. One of the big ones is the cost overruns on projects. So we have some places where we've had a history of overrunning every DCS upgrade project. And then the next project that you come up with, you bring that to management for approval, and they say, well, how am I going to believe this budget and this plan for this project when the last ones that you brought, you blew the budgets on those and you didn't make the plan? So it's important to learn from these past mistakes just for credibility in terms of justification of the projects and continuing to do our upgrades as we need to. When we do them wrong, when we underestimate the resources that it takes and maybe the engineering resources required, we can have real business impact. So delayed startups, impact on production, which can lead to an impact on customers. And in some cases, if you have too much of an impact on your customers, they may become someone else's customer. And that can be a serious business impact. So when we're putting together these projects, we have to think about the business impact all the way through. So not enough engineering resources, not understanding adequately what we had to do, and that means what we put together doesn't do everything we needed to do, and we end up with redesign, especially of logic and sequences. And this requires a lot of times for us to go back and rework that. So cost of the project doesn't just end when we do the startup. The cost of the project continues, a hidden cost to close out the project, a hidden cost of slowly redesigning all the things that didn't work right. And that can last for years to come. And that's a hidden cost that's in there. But it's a cost of productivity of the people, and then it's a cost of really the engineering resources that went in. And in some cases, that's a redesign of the HMI. It's so classic for us to focus on a P&ID-based HMI design, just P&ID-based HMI design, and to miss the operating tasks that go with that, not to perform any task analysis and understand that it's not just replicating what's on a display, but making sure the operator can effectively execute their tasks. And when you put in the first generation of graphics, then people have to come back and fix that so it really supports the operator's tasks effectively, and that can cost you time. But one of the hazards that we've got to talk about also from a safety standpoint, if we don't do that operator training, if we don't make that HMI effective, and we throw people into the environment of controlling sometimes a hazardous chemical process and not having adequate skill at doing that because of the change we've made, we can create hazards. There was the accident at the Bear Crop Science site in West Virginia in 2008. And this was, HMI was certainly not the initiating event in that situation, but it was cited by the U.S. Chemical Safety Board that they hadn't provided adequate training on the upgrade of their control system for their operators to be comfortable operating that. So that's one of those things where it's rarely cited in such a public report like that. Oftentimes we'll see it as a background contributing factor and just doesn't get shared enough that when we're doing a control system upgrade, there really is a risk for safety as well. So there's other things like the value of HART for asset management and alarm management you can roll into these upgrades. But those are some of the factors that we have there. So what I'm going to do now is pass the baton on to Matt, his section of the presentation, and then we'll take questions towards the end. So let me just advance the slide here and give the ball over to Matt.
Thanks, Nick. I'll jump in. This is I'm going to be mainly talking about migration planning, so the upfront homework that you need to do to have a successful migration project, to address some of the kind of things that Nick has been talking about. As Chad mentioned earlier, I'm the director of DCS Next, which is our, in Maverick, that's our DCS migration program, if you will. But and a little bit of what I'm going to talk about this morning, as Chad mentioned, is an approach that we typically utilize for migration planning, working with various individuals and customers. Fairly common, but it gets a little bit tailored here and there. But as Chad said, there's different ways to skin this cat. I think the main thing I want to talk about this morning is just, or this afternoon rather, is the need to do that upfront planning. However it's done, there's different ways to do that, but the need to get certain information and to do certain types of planning so that you make sure you don't have the type of incidents and overruns and that you meet your budget and your schedule and those kinds of things. So just to kind of really kind of tie into what Nick talked about, there's a lot of challenges, there's a lot of drivers of DCS migration projects across the world. The big obvious one is that OEMs are being forced to discontinue support of legacy DCS systems, primarily because they can no longer either obtain or manufacture certain components or parts or boards or whatever, and they're having to move away from being able to support some of the older systems. And of course that varies by platform. A lot of OEMs are doing as much as they can to extend the life and offer replacement repair parts, but at the end of the day, there are a number of platforms that are becoming obsolete or are already obsolete. In addition, as many of y'all may know, there's a lot of qualified DCS engineers on these legacy systems that have either left the industry through retirement or whatever, or are close to it within, say, the next 5 years. People that know Honeywell or Foxborough or Provox or an Old Bailey system. There's a lot less of those folks around than there used to be. And so that's a driver. The cost to maintain some of these legacy systems is beginning to get very high for replacement parts. Some folks may be going to eBay to get those kinds of things. To service them internally, and then also the actual service contracts. And then the final big challenge, I think, that's driving a lot of this is that you must run and change at the same time. That is, you must minimize downtime. You may have very limited shutdowns or turnarounds over the next couple of years, and there's a significant amount of the DCS system that must be migrated. So you've got to figure out how much can be done on a hot cutover and what can be done on very limited downtime, and what's the best efficient way to do that also minimizes risk. So those are just some of the challenges. People are also facing a lot of questions as they begin to, walk through this process. Questions that either they're struggling to answer or maybe they haven't even asked, but they should. Things like, how do I coordinate the migration with my outage schedules? How do I obtain the required funding? In fact, what is the process to get that required funding? This is probably, for many folks, the biggest project they'll ever be involved in as an automation engineer, and so that the process for getting multi-million-dollar worth of funding is pretty complex these days. How do you choose the right technology for your facility? Is it just a matter of picking the best technology, using the platform, the new platform of the same manufacturer you had already, or should you look at other options? What's the best way to plan the migration? What are the risks? Where will you get the resources, like Nick talked about? There is definitely a limited number of resources that know DCS systems and that are trained on them, and that can be a challenge. You need to think about that. And then how do I maintain and leverage the new system to increase profit? Is that possible? Is the only business driver that this old system is obsolete, or is there some benefit from a financial perspective, from a bottom line perspective to installing this system? And that, of course, can help you justify the project. And then finally, what's it really going to cost? We've found a number of times that, the hardware and the software and perhaps the engineering is pretty well estimated, but there's things like how much operator time, and how much maintenance time, and how much installation costs are being. There's typically costs that get left out in the process, and so you really want to know what's the total cost going to be, and how do we make sure we stick to them. So there are other challenges.
Hey, Matt, I'm going to jump in. We really got to have everyone muting, including if you're doing the integrated voice on the WebEx, because there's always feedback, even if you're in a very quiet room. The panel members' feedback on your computer will cause this hiccuping that we're hearing. So everybody needs to mute, and I'm sorry if you're on a phone that's can't mute or you're not in a position to mute, might have to ask you to drop off and catch the recording that gets emailed to you, because it's really impacting the presentation. Thank you.
Thanks, Chad. Thanks, everybody, for your help with that. And so there's also these, I'm going to, the next couple of slides, I just want to talk about the financial challenges, which often are the focus of procurement, senior management, and those that are writing the checks, and then the technical challenges, which are equally important. So some of the financial challenges I touched on previously, but this is a real challenge, and it's something that you need to think through and deal with, which is limited capital and expense dollars. This kind of gets into the second point, has there been any money put in the budget already, or are you starting from square one? Getting accurate TIC and TCO estimates, and let me pause there and just define those, because those will come up again and again. TIC meaning total installed cost. That's basically your take-it-home cost to install, engineer, commission that new DCS system, kind of the one-time cost. And then you have your TCO cost, which is total cost of ownership. So that's the long-term cost of owning and operating that system over its lifespan. It includes the TIC, but also the annual maintenance cost, parts, labor, software, you name it, everything including. And both of those are important. You need to not just look at one-time upfront cost, but the long-term. How do you objectively evaluate the options to get the best price? This is a financial challenge as well as technical. Who do you get involved in this process? Do you do it, as an end user, do you do it all yourself? Do you have the people to really do that? If you get some outsiders involved, who should they be? It's a valid question. And then finally, how do you develop a solution that delivers the most value and payback? And as I mentioned, there's not just financial challenges. You've got technical challenges to deal with, and questions and issues to think through. How do you use the software tools? I mean, there's a number of good software tools that can help do the migration, can help extract data, databases, programs from older systems, to some degree convert, but you have to be careful with those kinds of tools and use them wisely. Use them to your benefit, but don't use them when they could cause you problems. A more recent development is, of course, the ASM standards that are now in place now for abnormal situation management, and how that affects how you do HMI and alarming and even configuration that perhaps was probably not there when these original systems were put in. Again, developing a real executable migration plan that people can get behind and execute and deliver. Understanding, and this is a key point, I think oftentimes when we think about migrations, we focus on the what. What are we going to put in and that kind of thing. But it's really important to understand how you're going to do that. It's not just the what. So that's a key thing. So the technology, the cost, the resources, we've touched on a number of these already. And then finally, how do you leverage this new technology to reduce your maintenance on operations costs? You should see that go down. Increase reliability and reduce downtime of your older or existing system. Improve process performance in various ways. So those are a number of the challenges. What the latter kind of half of what I wanted to talk about today is just, again, the approach that we typically employ. This is a high to address migration planning and a lot of the challenges and questions, I've kind of thrown out there earlier. So this is just a high-level picture you see of beginning at FEL 0 or FEL 1 all the way through project implementation and then maintaining and sustaining and improving that that system over a period of 10, 15, 20 years. So this is just a high-level picture just to give you a flavor for that. And then I want to jump into a little bit more detail about FEL1 through FEL3. And then John's going to talk a little bit more about the project implementation through that case study. I'm going to focus a little bit more on this up front. So here's just a summary. And again, this is how we typically do it. This is common in a lot of process industries, a lot of customers that we've dealt with before. So this may be familiar to you. It may be unfamiliar. But in any case, I just kind of wanted to walk through this at a high level. So FEL1, really the purpose there is to look at a potential automation project at a very high level, kind of back of the napkin estimating, if you will. I don't mean that literally, but a very rough estimate, plus or minus 50% estimate on the project. You might typically look at a whole plant or whole mill, paper industry, or maybe multiple plants. And I'll talk about a situation with that in a minute. And so you see some of the key deliverables there. But really, again, this is a conceptual evaluation of a potential project. What's a rough order of magnitude on how much it's going to cost, and do we go forward? Typically, with a DCS migration project, you're going to go through FEL1 pretty quick. But you may make decisions in there on timing. You may have 5 years before you need to do something, and you could wait a little bit longer to do the FEL2. Or you may have a more pressing need, and you need to push forward as quickly as possible. So anyway, you go through the FEL1, and then on to the FEL2, which obviously is getting much more specific and better estimates. And so typically what we've done is that might be a whole plant, or it may be a major process area in a plant. Could be, in a paper mill, for example, it could be the powerhouse or the pulp mill or a couple of paper machines. It may not be the whole mill, but it could, depending on the way the system is currently installed. Or it could be in some cases where you've got multiple DCSs in a particular location. It could be the Honeywell system or the ProBox system that you're going to take a look at in your FEL2. The estimate accuracy at this point for the migration project is plus or minus 25%. So you're getting close or closer. You can see some of the key deliverables. I'm not going to highlight those too much because I want to talk about them in the context of like a case study or some examples in a minute. And then finally, the FEL3. You can kind of see how this flows. You get into plus or minus 10%. And really the key thing with the FEL3 is you're focused on an actual project. You're developing the final plans, the final estimates, and schedules and resource plans and risk assessment and those kinds of things for a project. And what should come out of the FEL3, assuming that it's approved and funding is approved and all those key decisions are made, is you're ready to start that project with a good plan, a good budget, a good schedule, and something you can execute. So that's just kind of the overview. So then what I wanted to talk about is, and I know this may be drinking from the fire hose, as Chad said, we'll post a lot of this or all this information, and you can go back through it, is to talk about this in the sense of like a case study. We have one particular customer we've done FEL1, FEL2, and FEL3 work for. So I thought it might be helpful to put some meat on the bones to talk about, well, okay, what does this really look like? What are the deliverables, and what are the benefits? Why do it? How does it answer those questions and those concerns and challenges we were thinking through earlier? And so here's an example of an FEL1. I won't mention the customer's name, but it was a large paper manufacturer. And so you see some of the deliverables there. There was an enterprise-level survey done of all 13 of their mills. Again, we're not getting down to every little piece and part of the control system, but a high-level survey of everything they have, both DCS and PLC. In this case, plus or minus 50% estimates were done. And then a multi-year capital investment plan was put together essentially for the whole corporation. And let me kind of skip down and talk about some of the benefits, because I think that's really where it hits home. So I talked about the first one a little bit there, that in this case, this customer received a high level, an enterprise level, and what I mean by enterprise is corporate level synopsis of all their automation systems across their entire enterprise at all their production facilities. And I'll get to why that was important in just a moment. But and so that included the relative size, how big are these systems, how many I/O, how many controllers, the vintage, what's the age, what kind of platform is where, and then the status of each. Where is each platform, each control system in its relative lifespan? Is it current, active? Is it mature? I'm probably using terminology many of you are familiar with. Is it mature or is it obsolete? And so then what was done, or the benefit that kind of resulted from that, is an overall risk assessment and a multi-year migration schedule and a capital investment plan, meaning they could understand, okay, which systems at which plants or which mills need to be dealt with first. And so there was two key factors there. One is the relative priority of migrating that platform. Is it obsolete? How much longer can we get support? Is this one of those things we've hit the brick wall and we've got to do something right now, or do we have some time? And how much time do we have? And then the second big factor was, what is that mill's relative priority to the entire corporation? So if you have two or three or four facilities with the same system, can you migrate them all at the same time? Maybe. Can you afford to do that? Maybe not. And so you may need to go through a thought process of, well, which one's most important? And we got to hit that one first. Then we could perhaps free up spare parts to send to the other locations. These are the kind of things that an FEL1 would go through if it was done in this fashion, where it was an entire enterprise. Again, it could be done for just one particular location. But I wanted to highlight that because it was, I think, a good example of taking a look at an entire enterprise and then, making some tough decisions about which ones were most important. And because you only have so much money to spend, you got to spend it dealing with the most important ones. Let me jump to the second example, which is an FEL2. And I'm going to mainly focus on the benefits again, so just to move forward a little more quickly. Again, FEL2, plus or minus 25%. So the benefits in this case of this particular study that was done was the fiscal approvers, that is procurement, high-level management, mill management, the people, again, that have to sign on the dotted line for those funds to be released. They received a solid business case for the migration and a highly reliable understanding of the multi-year capital and expense spending requirements. Nick talked about earlier about how so many projects go over budget. The end purpose, or one of the end purposes of doing this, is that doesn't happen. And to make sure that doesn't happen, everyone needs to do their due diligence to make sure that you've got a highly reliable estimate and business case. Or else the next time you go for money, it could be a lot more difficult. And secondly, though, the technical staff, because of one of the things that happens in an FEL2 often, but not always, because there's variations to that, is you may compare platforms for what should be the replacement platform. Sometimes that decision's already made. Sometimes it's part of the equation. So in that case, though, that what should happen is the technical folks, the engineers, and the other folks that deal with the system every day, have confidence in the selected platform because it was a very thorough, objective evaluation done, and that's significant. The other couple of things we saw in this case, and this, I would hesitate to say this is completely normative, but I think it's something to have as a goal, which is you should have, if you do have multiple vendors in this part of the process, you could have significant savings because of the competitive situation. And so in this case, there was 30%, greater than 30% savings compared to the estimates that were done in the FEL1 that were based on one vendor. So when multiple vendors were involved, there was some cost savings. Again, not necessarily normative, and it depends on the situation, but that is something to think about. And then finally, it provided the corporate procurement folks with a lot of leverage and information in their final negotiations, and everything was kind of on the table at that point, and there wasn't surprises later of things that weren't talked about up front. And so that was just another example. And then finally, the FEL3. Again, this was the real key point here I want to make is you're getting down to brass tacks. Plus or minus 10% estimates on the cost. You have a preliminary project schedule that's based on when the plant or when the mill can be shut down, how much can you bite off at one time, how will the actual commissioning and training take place. It's an actionable execution plan that includes budget, schedule, resources, risk, so that the idea being if someone says go, you're ready to go, and you've got a plan. And so, again, the FEL3 is an actionable project plan and kind of everything that goes into that. And so, I would just highlight the last bullet point there to close this up, which is you have an achievable project execution budget, a resource plan, a schedule, and then you've got high confidence that the project's going to be successful. And I would just kind of go back to talk about some of the things I mentioned earlier about the challenges and the questions, and even some of the things Nick mentioned. You always want to go back as you work through this process, the FL2, the FL3 in particular. You want to make sure you're answering those questions, and you're filling in the blanks, so to speak. And if there's something you realize you missed, go back and look at it again and make sure you've dealt with that, because it's better to deal with it up front and get your blueprint right before you start building the house. And so that's really the main thing I wanted to focus on. And with that said, I'll transfer it over to John. And John, just a moment, I will give you the presenter rights. And John can talk about this migration project in particular here.
Morning, this is John Boyd, and I'm going to go through a case study for DCS migration from Westinghouse Distributed Processing Family to PlantPAX, balance of plant. And for anybody that's not familiar with the balance of plant, it's basically the control system that ties in all the different components at a combined cycle power plant or most power plants. So the agenda to kind of go through the process of a DCS migration for this customer. This project started. We were given the notice to proceed in February of 2012. We completed on November 19th of 2012 with the startup to full power on that day. And to just kind of go through why the customer decided to migrate their DCS system, how we migrated them through that process, and in the end kind of show you what the PlantPAX system, this is a migration, not to a in-vendor migration, so this is across different vendors to kind of show you that process. And to kind of introduce you, Rip and Cogen, this customer's in California. They have multiple combined cycle cogenerations. This one happens to be in Ripon, California. It's a 50 megawatt General Electric LM5000 gas. And this customer would entertain any questions directly. If you just direct those through me, they'd be happy to tell you about their experience. So, in the start, why did they want to migrate their DCS system? Their control system hardware was 7080s technology, very proprietary, to the point of not being available unless you go through some of the refurbishing warehouses to get any of the parts. And again, you didn't even know if those were reliable spares. And it caused a lot of downtime. Just a few people in the United States knew how to work on it. These were early WDPF or Westinghouse systems that had very few people that knew how to work on them anymore. The other thing was the control system software was a proprietary operating system with no vendor support. Their historian had failed, and they had basically all the reports had to be done by basically sneaker reports. Everybody had to go around and collect information, and eventually made it to the front office, and then they fill out Excel reports to go into their compliance reporting. To look at their new DCS system. Some of the things that they looked at are basically minimum requirements. They wanted the state-of-the-art hardware. So they wanted the newest hardware. They didn't want older hardware that they'd have to go through this process again, or, maybe some hardware that had come out in the last couple of years. They wanted open control networks, no more proprietary networks. They wanted support by local integrators, and they also wanted to take advantage of HART, smart transmitter communication, and so we were able to add that into the system. They wanted open Microsoft desktop and server operating systems, historians, and again, wanted nearby support. And then as we went through the process, so as we went through this migration process, we had to discover the existing system. Fortunately, Maverick has ex-Westinghouse engineers, DCS engineers, that were able to take the original files and software and provide a base functional specification or control description. And then we sat down with their operation and maintenance staff, and even the plant manager, and went through every control strategy and looked at what they had and if they even wanted that anymore, and then also enhanced it. So as we went through all that, then we finalized a enhanced or the final description. And then we used standard objects that came out of the PlantPAX system. Didn't have to develop any customized system, so we were able to take advantage of all the advanced HMI objects, technologies, and we didn't have to stick with any of the old technology or why things were done a certain way, as Nick had talked about in his session. And the other thing that the customer decided is, let's upgrade the PlantPAX or the balance of plant system, but let's also migrate all of our silos of automation, be it our chiller system, our distillery system, water distilling system, and also their turbine control system. We're all running off underwear HMI systems that were some were arc test, some were older in touch. So we migrated all of those, basically just the HMI portion of that, into the PlantPAX system. So this is basically the architecture that was existing. They had drops and redundancy for 3 drops. They had operator workstation, a couple of operator workstations, and an engineering workstation. And then so we migrated that to the new architecture. This is basically a Microsoft Active Directory using a primary domain controller for the whole control system, redundant HMI servers, and also a Historian SE, which is OSI Pi, and then also Vantage Point, so they can now have automatic reports and have those automatic reports automatically fill for their compliance. And one of the things that came up, the customer just last week called and said, hey, guess what? NERC has a new GADS that we have to perform. And we were able to set that up with or get that information for them for all for the plant floor, all the points that we already connected to. We easily gave that information to them, which would have taken a lot of work to get that report out to NERC. This was their original screen. Obviously, we didn't want to duplicate these screens. And this is basically what they ended up in their control room. They have 2 operator workstations with quad monitors, and then also a 9th monitor that runs off of one of the operator workstations. And all these screens are independent. They were able to have multiple operators in the control room if they have any upsets or bumps, maintain and help themselves get through any bumps in the process and prevent the plant from shutting down. Some of the things that we did with a hardware migration, and this is there was planning around this. We analyzed the DCS hardware that was there. they had Pneumologic I/O, which is the old Westinghouse PLC I/O on the DCS. So we got a plan together for migrating that to just having enough electricians there to move that I/O over one of the swing arms. So that all had to be hand rewired. And then we looked at their the Q-line I/O, which Westinghouse DPF I/O, that we were able to use interface cable. So there were modules that could interface with the swing arms of the old Q-line to go directly to the new control logic Rockwell arms. So this is a picture kind of showing that migration. These are the Westinghouse DPF processor drops and the old racks, and we use the existing enclosures. So note in this process and the plant, we used all the existing enclosures. So this is a new backplane, the redundant processors, and this is all over Ethernet communications, both for separate HMI or Ethernet communications for the HMI side, and then all the I/O is over redundant device storing. You can see at the bottom, those are actually the Q-line swing arms that have been mated to the interface PC boards, and then it goes straight into the I/O. So we didn't have to do any rewiring except for switching some power, as you see to the right. The Pneumologic I/O, you can see their standard chassis I/O, and that just had to be moved or migrated over and run the terminal blocks straight over to the new control logic. This is a picture of the actual interface, and I would, highly recommend you look at these. Really allowed us to migrate them over very quick on the racks and cabinets that had the Q-line I/O. I probably cut our time by 75% in the over process. So there's a lot of manufacturers of this. This is a separate company that makes these swing arms and migrations to many other PLCs and also DCS. So, here's the old Q-line rack on the left, and this is the new panel laying on its back, and you can see we laid those out perpendicular to the back plane. And then when they ended up going in, you can see the same Westinghouse Q-line cables to the field termination blocks, just swing 90 degrees and locked right into the new arm. So had zero issues with any connections from the new I/O cards out to the field devices. The continuity checks were 100%. So this was the original control room. Again, turbine control, the original 1970, early 80s control room. They had multiple displays. Each one of those displays, except for the two Westinghouse consoles, were all silos of automation. In fact, the display on the left, the larger display, had 4 different Wonderware applications running on it. This is another view of that same as we're adding the 6-inch monitor, and you can see the turbine control system, the consoles, and the operator, if they had an issue, had to go to each one of those or go to the console and change each one of those screens to figure out what was going on in the plant. So this is, again, some of our engineers out in the field cutting over the system. This is one of the process screens. So you saw some of the process screens earlier. This is the heat recovery steam generator. So now that this was on multiple screens on the old Westinghouse console, so they weren't able to look at everything at the same time, and now they can. They have full security around which templates can be touched or which objects can be touched based on what operator or engineer maintenance personnel are there. This is their ammonia process. Again, just showing you the screen and what they migrated to. Full alarm system on the lower left is the dashboard. And this is a gas compressor screen. And one of the things I wanted to point out, another thing that we ran into is at the same time that we were doing this migration, they decided to fully overhaul their gas compressor system. And through that process, it wasn't really planned, but it really extended the time it took to migrate or do the startup, because they had a lot of mechanical issues with all this rebuild equipment. And so that, it's one of those things you want to add to the schedule if during that migration process, if other parts of your process, the mechanical engineers decide they want to do overhaul, you just need to add some of that time into the schedule. Luckily, we had enough slack in our schedule that we could accommodate that additional testing. Their process cooling water system, this was all, again, they didn't have any of the screens in the old system. That was all text. And then just some of the standard high-performance HMI templates. These are standard and follow the high-performance HMI standards now. And with that, again, the customer would love to share his experiences, and if you'd like to talk to him about that experience, just shoot me an email at the end, and I can put you in touch with him. And I'll pass this back over to Chad here, and I appreciate your time this morning.
Thanks, John. That moves us to the Q&A portion of the presentation. I wanted to let everyone know that for additional information following this, I'll pull this back up in a bit, but you guys are free to contact any one of us if you have questions or follow-up discussions you would like. We're all available. You'll be receiving an email that has the recording link and some supporting information as well. And as I mentioned at the beginning, if because we don't have the opportunity to have everybody open on the lines on the phones and have open discussions, if you have a lesson learned or a comment that you'd like to add to the discussion, please email that to me, and we'll include that in a collective entry. For questions and answers, please feel free to submit to the chat tool in the WebEx window, and go ahead and enter any questions there. I've had a couple that have come privately. One I'll direct Nick Sands, and Nick, I'll open it up to you. It's a question about resource loading on projects, and you seem to have some experience there. So do you have any insights into how to determine how big your project team needs to be for one of these?
Wow. It's a pretty general question. I think that the part of that really gets back to understanding what you really want to have as far as functionality in the new system. And you can, for some continuous processes, you might be able to look at, there might be some general rules around the I/O count that you could look at. When you start to talk about the batch processes, though, I/O count's not going to be a good metric for you to base estimates on, and you're really going to need to understand more about the phases that you're going to need to add and the operations that you're going to need to add in order to be able to do that. I'd say for more guidance, more detailed guidance on how to do that estimation of resources for a project is probably a webinar by itself. But right. Chad, maybe you have something to add from the planning standpoint?
Well, I think then that, or Matt.
You're talking about resource planning?
Yeah.
Yeah, I mean, I think this kind of goes back to one of the things I was highlighting earlier. In thinking through estimating, I think one of the things you want to do besides estimating the tangible cost, you want to do a really effective estimate of your engineering and your commissioning costs, the manpower costs, and that should have a blend of a team. So what kind of team do you need to put together to accomplish that project? So it involves both man hours and then your schedule. And so those two being the two big variables. And so once you've kind of thought through your team and estimated the man hours, and you understand the time that's going to, what is this a 6-month project, a 3-month project? Are you going to have 2 days to cut it over or 7 days to cut it over? And so there's going to be certain fixed variables that you need to know up front and account for, and then you need to develop an estimate that has all the man hours and you haven't left anything out. And then you can begin to map that into a project schedule and a manpower schedule. And so, what we typically do with that, once we have a solid estimate, is we'll map it into Microsoft Project, sometimes other tools, and then let that drive our resource needs. And then once we know, okay, we need this kind of resource and 2 of that kind of resource and 3 of this kind of resource, then we fill in those with the best resources we can. So I think, again, you've got to let that upfront planning and estimating, both from a schedule and cost standpoint, drive your resource plan, rather than saying, well, I think this is a 4-man job, and then go from there. So that's how I'd recommend it.
Okay, thanks, Matt. I got 2 similar questions here. One is they both have to do with the technical evaluation piece. One's specific to the case study. The other one's more general. So Matt, the first one is, what is the best way to do a technical evaluation? A true technical evaluation is the question. So I'm assuming just kind of a touch on kind of the process to do a technical evaluation.
Yeah, absolutely. That's a great question. I think so. If we assume at the very beginning, yes, we want to do a technical evaluation. That's a valid question. Some folks are not in a situation. A decision was already made. To go with a certain OEM corporate-wide, for instance. So as soon as you're going to do an evaluation, I think there's 3 big key questions you got to answer, which is who, what, and how. Who should be involved in the evaluation? I think that the mistake can be to only involve a select few controls engineers, and certainly they need to be part of it. But I would also recommend that you have a diverse team of, some folks from operations, maintenance, plant management, maybe even outside resources that can kind of give you an objective opinion. They're not biased. And so think about the team that you have be a part of that. You don't want it to be too big, but you want it to be diverse. So you get buy-in and you've got different viewpoints. The same thing is the what. So you do need to do an evaluation. I wouldn't recommend looking at 7 or 8 different platforms, but 2 to 4 is probably a good number. And one of the things I would recommend is, often you're probably going to be looking at the existing platform, the newest iteration of that from that OEM, and that's understandable. Probably the wise thing to do. I would look at another platform that is a common competitor to that one. You guys know who those are. And then I would also maybe think about sort of a stretch one. Think outside of the box. Is there another platform that maybe isn't the obvious competitor, but it could be because of some recent developments and capabilities? It could be something you should look at. So again, you need to make a preliminary determination of which ones. And then the final thing that I would really highlight is the how, which is what I think you were getting at, which is you need a methodology and tools to objectively compare the platforms. So, and what we do is we have what we call a comparison matrix. Call it what you want, but you need to look at the technical criteria. Those need to all be identified. What are you going to compare them on? Things like uptime and CPU capabilities and all kinds of things. So there can be 100 technical criteria. So you need to identify those, and you need to figure out how relatively important are each of those. Some are really important. Some are, that'd be nice to have, but you're not too worried about them. So you identify those criteria, you identify the relative importance, and then you use your team and resources as needed from whether it's OEMs or whoever to evaluate how well each system stacks out on those criteria. And the key thing here is, as much as possible, take the subjective out of it, make it an objective thing. I mean, there's always going to be some personal bias here and there, and that's understandable. Put that on the table and try to be as objective as possible so that, as I mentioned, the people that are going to approve the dollars and the people that are going to live with the system for 20 years are happy with the result and they're bought into it.
Okay, thanks, Matt. John, there was a specific question to your case study on that exact item and whether how did the selection process take shape as far as choosing PlantPAX versus Ovation or some other option there?
Yes, thanks, Chad. The customer had already settled on a PlantPAX solution. They had already done a lot of research themselves. Their sister plant down in San Gabriel, California, had already migrated from Westinghouse to the Ovation system. And based on that, they wanted to look at other avenues because they felt they just got right back into a proprietary system. And in the end, the big driver was cost. The PlantPAX system was considerably less than the straight as-is migration from the Westinghouse system over to Ovation.
So you think at the end of the day, it was largely a cost decision with kind of a technical evaluation, but it definitely hinged on cost and ease of implementation as well.
Yes, it was. A lot of it had to do with cost. They had already experienced going from the Westinghouse to Ovation, and then also when their minimum criteria is it must be an open system. They wanted open networks, common OS system, or operating systems for their computers and hardware. So that was the other deciding factor. Yes. Okay.
Good. For that. We've got a question about determining what information is captured from the existing system versus a clean sheet of paper design. And I think I'll take that one in that, there's several different ways you can do a migration like this. Projects that typically try to ignore the existing system and go with what we'll say a clean sheet of paper, or just go straight to functional specs that are done from scratch. That's a feasible solution, but what we've found historically is that you're always going to miss something. Even if you take a real deep look and you think you know your plant 100%, there could always be a line of code or a script on a screen or something that's doing something that you missed and didn't get documented in the new design. So we really prescribe to a combination of that, which is to completely document the existing system, both HMI and control strategies, and prescribe to something similar to, we call it no code left behind. You really have to make sure you've accounted for everything. That doesn't mean you've reprogrammed that exact line of code. It may not be necessary in the new system, but it needs to be accounted for. And the reason in doing that is when you get into startup, or if it's a hot cutover especially, you don't want any process upsets because you miss something. So I think a combined approach to that is the right tack to take, where you definitely account for everything that's in the existing system, and you redo new functional specs for what you want the new system to do for you. And it's a combination of those two things that drive you to where you need to go. So I think that's a good question, and that's at least the approach we've seen be the most successful. We have another couple questions about the HMI screen design and layout, really focusing around how much involvement the operators have in the design and layout, and how do we make sure that the operators just don't request that you have like-for-like graphics. I think I'll pass that over to Nick. I think you've got quite a bit of experience there that you could draw from.
Sure. What we found is that the operators we want to have, first of all, their input, and if we can get an operator on the team to help with the design of the HMI, that always works out best. but we don't anymore just give them the freedom to do the design. We used to do that, and we ended up with some of our colorful Christmas tree graphics, and they didn't necessarily understand the concept of the hierarchy of navigation hierarchy for displays and the different types of displays. But what they're really helpful with is when we come up with the display and we look at the operating procedures that relate to that display, the operator can help highlight what's not even in the procedures around when they're performing a task. What information does it take for them to perform that task? Do we need to add something onto that display so that they don't have to change displays back and forth to perform that task? So that's one of the big areas that we rely on the operators for. And then another one is to understand the key performance values or the key indications or key controls for a certain process area. We'll typically start by laying out the main layer of the display, the navigation hierarchy, those main operating displays. And as we build the higher level displays that are more abstract, we just need to focus in on the key pieces of information. So that operator involvement's great there. Now, if people have talents you can take advantage of. If you have some of those folks that that happens to be something that they're really interested in, passionate in, I've seen a lot of operators become DCS technicians because they really like to work in that operator interface, and they really buy into those concepts of making sure that that display works well with the operator, and the operator's trained well to work with that display. So I think that's it. Now, the ISA 101 standard, still in draft, is targeted at those kind of things, trying to help folks understand that process of going through and developing displays. So you've got the steps of developing a toolkit and a philosophy and approach to that, and then going through and understanding what tasks do you have to support for the operator. On the other side is the situational awareness, making sure that those displays at a high level tell the operator which direction is the process going, and is it good or bad, and how fast is it heading that way. So kind of trade-off between the task side and the awareness side in that hierarchy. So hopefully that's some helpful information.
Yeah, thanks, Nick. I think we've seen as well, and people may be running into this as well, a difficulty in convincing operators to adapt some of the new functionality and some of the new standards that are out there. You know, there's the running joke about the gray on gray, and the operators freaking out about things like that. Yeah, it really comes down, at least in our experience, to having the operators on board early and explaining the reasoning behind it and why it's heading that direction, and the fact that it just doesn't make sense to set up like for like HMI anymore. Otherwise, you're going to be running on 1980s graphics in 2030. So I think.
Can I add something to that?
Yeah.
This Nick Sands again. One of the things that we've done is use the cascade style sheets, and when we have an HTML-based display, and so we'll assign all the objects, never directly assign the object properties, but assign the object properties to a cascade style sheet object, and then they're parameterized. Then you can use the same display, and you can first let them keep their colored lines and just change the background, and then after a period of time, when they've become acclimated to that, you can start to change some of the line colors. So you can actually accommodate the operators. And what we'll do in some cases is to build a display with a toggle switch on it that says, well, we start off with a colored version of the display that's similar to what they had. They can hit a toggle and it changes it to the grayscale. And after a period of time, switch the default of that toggle so it comes up the grayscale display, but they can always toggle it back to the color display. And what we find out is, over time, once we flip that toggle, they stop using the toggle to go back to the color display, and then they're just operating on the grayscale. But at any point in time, if they wanted to, they could switch it back. So even the technology itself can help facilitate that transition. Okay,
good. And one thing we've seen there as well is the actual effort to create those color displays and make them look like the older system is actually quite a bit of work. And in general, and I think this is a fairly generic platform independent comment, Most people are better served by using the out-of-the-box libraries that come from the vendors. Even if they're making some concessions there because of release upgrades and things like that, if you have a highly customized set of shape libraries for your graphics, then you're going to be in a big maintenance mode every time you do an upgrade to your system. So that's something to consider as well. All right, we have another question about conversion software and writing code from scratch, and I think that may be directed to John Boyd specifically, but I will say generically, conversion. There's a lot of products out there. There's a lot of toolkits that the various the companies and integrators have. If it helps do the job, great. If somebody is selling you an automatic conversion toolkit that's going to automatically convert one DCS programming set right to another, be very wary and ask a lot of questions, because that's not something that typically has been shown to be possible. In the attempts that have happened out there in industry, there's quite a few products that can get it to 80%, but what we find is you spend so much time trying to figure out what the 20% is that didn't get done that it becomes a big mess. So automatic conversion of code to code is very dicey, but if you have available toolkits or access to toolkits that can help with the reverse engineering or documentation of the old system and make sure that you're not missing anything and can get that into relational databases where you can keep things organized, that is all hugely important and impactful on your project. So hopefully with those type of tools, you can get most, if not all, of your I/O and single loop controllers done in an automatic fashion, and then how you attack custom code and scripting and things like that is something else that you have to look at entirely. John, do you want to comment on what you guys did specifically on the Ripon job?
Sure. What we looked at is we looked at the original Westinghouse control strategies, and again, the customer did not want basically a rip and replace and a conversion over to what they had to a new system. They wanted it completely enhanced. So we basically looked at all the control strategies and used the enhanced each one of those strategies, and then basically we were able to use a vast object library within the PlantPAX system, and we didn't have to create anything new. So like Chad was saying, as they migrate from one version to the next, they won't have any issues. So we didn't start from scratch because we had a lot of the objects that were already in the PlantPAX objects library, so that we were able to rapidly develop the project. Thanks, Chad.
Okay. And there's another question that came in about, and I think we'll hit this on multiple members of the panel here, but John, I'll let you follow up first. Question is, has the client recognized significant operational improvements with the new system, and where did we see the biggest impact and payback? Has that system been in place long enough for you guys to kind of see how it impacted the overall process?
Yes, they have seen a significant improvement in being able to respond. They're able to see parts of the process they didn't see before. With the multiple screens they have now, they can actually see what's going on within the feed system and some of the auxiliary systems and respond much quicker to upsets, to process upsets, and some of the advanced process control that's built into the PlantPAX system. They were able to control things they weren't able to control before, and their system prior to this, they would have I/O drop off, which would cause the complete shutdown of the plant. that has not occurred since then, and they've also been able to recover low drum levels and loss of feed water with automated auctioneering and backup and standby systems. So they've seen it basically outside of mechanical issues they've had with the turbine or one of the other systems. They've had zero downtime. So they are extremely happy with their system, and again, they would be happy to talk with anybody that would like to talk directly with them from the customer's standpoint of their experience of a DCS migration. Thanks, Jeff.
You'd say situational awareness for the operators, and then just reliability improvements just based on how bad things were getting with the old system. And I'll also ask Nick to comment as well, because I think Nick, out in DuPont, I think you've seen some degrees of this as well.
Yes. Well, we've certainly seen the places where we've waited for a long time for our system replacement. I remember replacing a Leeds and Northrop Max 1 just a few years ago, and one of the big challenges there is every time we had to make a process improvement, we have very limited capability left in that system, and there were very few people left on the planet that were familiar with the Max 1 and still willing to work on it. So that kind of constrained our ability to make process improvements, even meeting new environmental regulations and new operating goals or any improvements for trying to improve our production capacity. So one of the big things we've gotten is flexibility when we've increased the capacity of those systems. And then we get a lot of benefit, frankly, from doing cleanup, from understanding what's actually in our system and getting rid of dead code that we have there, or things that we had forgotten that someone had abandoned before, and making the improvements of things like the improved operator interface and the HMI. So in general, what we see is where the project is well executed, increase in uptime and capacity for that return on investment.
Okay, thanks, Nick. There's a question about, and I think it's follow-up for you, John, specifically on Ripon. Did you guys do any predictive modeling controllers on that? I have a follow-up as far as APC in general, but specifically, did you guys do any sort of MPC on that?
No, there was no advanced process control beyond using some of the advanced blocks that are in the PlantPAX system, but no model predictives that was used on that.
Okay.
And also to add to the other, as far as what the customer has seen, prior to this, it was very questionable to even open the doors on the drops, so they didn't want to shake the equipment. Everything had become very loose, and they basically, to change any cards out or work on it, they had to shut the system down. Now they have a system that is completely redundant. You can change the processor and I/O cards while it's running, and you can actually change out all the I/O cards. One I/O card not affect anything else. So that's the other thing they've experienced. Not that they've had to do that, but now they have the confidence that they can go up and check the I/O cards and not worry about a loose connection or delicate stuff causing them to shut down again. Thanks, Jeff.
Okay. And I'm going to follow up on the APC part, and just for clarification for those that are left, at least in Maverick, we describe APC as not only the multivariable products that are out there, but also regulatory control and model predictive control as well. So it includes the whole gambit. In general, during a migration, it can be an ideal time to look at that, whether it's just having that in mind for future, and once you've got things cut over, that's your next implementation project. It could also be a time that if you've got deactivated APC strategies or controls and third-party controls, looking on how that can fit into the new system. Some of the new DCSs, you can do a lot of stuff internally, and you don't have to pay for additional licensing from third parties and whatnot as well. So that all comes into play. I've been on several migration projects where we commissioned the APCs right along with the IO, and then I've been on others where we just suggested improvements for the future, and that was not part of the migration project, and that was handled under a different bucket of money. So there's a bunch of different ways to do that, but it's definitely something that should be considered in your upfront planning. All right, I don't see any other questions coming through the chat, I believe we've, unless anything pops up here real quick. Like I said, for follow-up, feel free to contact any of us via email. We're open to continued discussions, and if you have, I'll remind you, if you have additional lessons learned or would like to kind of comment on a case study of your own, where you have some lessons learned you'd like to share, please send them to me at chad.harper@mavtechglobal.com, and what we'll do is we'll compile those and include those as a blog entry someplace in the link that goes out, so that you guys can provide some. I appreciate everybody's time. Thank you for joining. We had a big crowd, and thanks for making it through the occasional technical hiccup and audio issues. But I appreciate everybody's time, and thank you very much.
Thank you.
Thanks.